All right, today we are continuing the 7.1 geometry notes. So we're going to start with some vocabulary. So when we have an equilateral polygon, it is a polygon where all the sides are the same length, which is congruent. So all sides are congruent. That is an equilateral polygon. When we have an equiangular polygon, all of the angles in the inside, the interior angles, are also all the same, which means they are congruent. So you can see on the image up here, this polygon right here has all equal sides, but the angles are different sizes. This polygon has all equal angles, but the sides are different sizes. So when you have a polygon that is both equilateral, so same side lengths, and equiangular, then it is what is called a regular polygon. So a regular polygon has all equal sides and all interior angles are equal. That's what it is to be regular. All right, on example 4, it says a home plate for a baseball field is shown. Is the polygon regular? Explain your reasoning. Well, if the polygon is regular, we would have to know that all the sides are equal and all the angles are equal. So when I look at this, I see it has 5 sides. So if n equals 5, using what we learned in the first half of this section, I can find out the number of interior degrees using n minus 2 times 180. So if I do that, then I'm going to have 3 times 180. Calculator here. All right, so that's going to be 540 degrees. So if these two angles are equal, I can call them x. And what I find out is that 2x plus, see how there are 3 right angles? 3 times 90 degrees is 270 degrees, equals 540. So if I solve for x, I can subtract 270. And so I find out that 2x equals, I subtract 270, it equals 270. And then I divide by 2, and I get x equals 135. So right there, you know the angles are not equal. Honestly, I could tell by looking at angle E and angle A and see that angle E is not a right angle. And so it's not regular. So it's no, not all angles are congruent. And you can also tell by looking at, like, for example, side BC, this side is definitely shorter than side AB, so not all sides are congruent either. So it wanted us to find the measures of angles C and E. I kind of jumped ahead on this, so I think I kind of skipped ahead on the program. I apologize for that. So we know that all the angles equal 540 degrees because I used the formula for the interior angles. And then I add up the 5 angles and they equal 540 and I solve for x. So angle C, the measure of angle C, and the measure of angle E are 135 degrees. All right, so on example B over here, it says, look at this polygon. Is the polygon regular? So, and it wants us to explain our reasoning. So right now, just by looking at it, we can definitely tell that when we look at it, we have a 160-degree angle and a 100-degree angle. So right there, we know that it is not regular because regular means all equal sides and all equal angles. So we can totally prove that not all the angles are congruent. And you can always use the word congruent, or this is the congruent symbol. It's the equal with the little squiggly above it. So that would be a possibility also. Now it wants us to find the measure of angle B. So see how B has this congruence marking? And it is equal to G, and it's equal to E, and it's equal to D. So if those 4 are all equal, they can be represented by X. So if we add up all the angles, we have 4 X's plus 100 plus 160 plus 140. Now, I need to know what this equals. So how I can find the sum of this figure is I can count up all the sides. So the number of sides here is 7. And then I can use the formula n minus 2 times 180. So when I use that formula, that gets me 900 degrees. So that tells me that this entire figure, the sum of the interior angles is 900. So I'm going to go ahead and add up these angles right here, 100 plus 160 plus 140. That's 400. And then I just subtract 400 and then divide by 4. So I get 4x equals 500. And then I divide by 4. And so that gets me x equals 125. So the measure of angle B is 125 degrees. All right, let's go ahead and turn on over to this last page back here. Okay, so the polygon exterior angles theorem. So the exterior angles are on the outside. So the sum, so when you add up the measures of all the exterior angles of a convex polygon, each angle adds up to, when you combine them all, they add up to 360 degrees. So exterior angles are formed. So for example, if I have just kind of a random quadrilateral here, exterior angles are formed by extending each of the sides. So if you keep each of the sides going and you add up, like this is angle 1, angle 2, angle 3, and angle 4. They add up to 360 degrees. And it does not matter how many sides you have. If you have like a 12-sided figure, all of the exterior angles still add up to 360 degrees. So this says find the value of x in the diagram. So it does not matter how many sides there are. We know that the sum of the exterior angles, meaning when we add up all the exterior angles, it's 360 degrees. So we have 2x plus x plus 67 plus 89 equals 360 degrees. So I'm going to combine the 2x and the x and get 3x. I'm going to combine the 67 and the 89 to get 156 equals 360. Now subtract the 156 from both sides. And so that gets me 204, and then I'll divide by 3. So x equals 68. All right, so if you look at this figure, these are exterior angles. If I look how many sides there are, there's 1, 2, 3, 4, 5, 6 sides. But it doesn't matter that there's 6 sides because no matter how many sides, the sum of the exterior angles is 360 degrees. So I can add up 5x plus 62 plus 35 plus 69 plus 41 plus 58 equals 360. I'm going to go ahead and use my calculator to add up the other angles, and I get 265. So then I subtract the 265, and I have 5x equals 95. I divide by 5, and I get x equals 19. So when you use the formula n minus 2 times 180, that's when you're finding the sum of interior angles. When you want the sum of exterior, that is always 360 degrees. Okay, so let's look at example 6. So this trampoline is shaped like a regular dodecagon. Dodecagons have 12 sides. Find the measure of each interior angle. Okay, well let's start with the sum of the interior angles. So if we plug in n minus 2 times 180, we find out the sum of interior angles is 1,800. That's the sum of all the angles. Now, if it is a regular dodecagon, that means all angles are equal. So that tells me that there are 12 equal angles. So I take this sum, the 1,800, I divide by 12, and I find out that each interior angle is 150 degrees. So now I know the sum of exterior angles is 360, no matter how many sides. So if I am dividing that by 12 exterior angles, I do 360 divided by 12, and I get 30 degrees. And it actually makes sense because 150 plus 30 is 180. And if you can picture, if you had this angle here inside is 150, then it makes sense that this angle here is 30 because together they form a line. All right, last but not least, this earring is shaped like a regular hexagon. So regular means all equal sides and all equal angles. Hexagon means 6 sides. So it wants us to find the measure of each interior angle. So first let's find the sum. So the sum of the interior angles. We're going to plug in 6 minus 2 times 180. And so we get that 720 degrees is what it adds up to. Now, since it's regular, that means all the interior angles are equal. So you take the 720 and you divide it equally by 6, which is 120 degrees each. So now for the exterior angles, the sum of the exterior angles is 360, no matter how many sides. So you have 6 exterior angles since it has 6 sides. So you take 360 divided by 6, and each exterior angle is 60 degrees, which once again makes sense because if this was 120 degrees for an interior angle, when you extend the side, here's your exterior angle, and it makes sense that would be 60 degrees. Together they form 180 because they are a linear pair.